All right, Chapter 10, Site-to-Site VPNs. This is an extension of the previous chapter that we just went through. We were talking about the basic concepts of IPsec. But in this case, we're going to take a look at some configurations. We're going to take a look at building a site-to-site VPN between two Cisco iOS routers. The principles are the same even if it's an ASA. All right, even though the syntax is slightly different, the process we go through to establish the VPN between two ASAs is slightly different. But overall, the framework is the same. The general concepts are the same. So we're going to spend a little bit of time doing that. Normally, I don't usually do the demonstration here, but I thought, what the heck, we might as well go ahead and take a look at this in command line. So obviously, we want to make sure that we establish, well, in this particular case, we're going to establish a VPN connection between two routers. We'll assume that, or at least kind of make the assumption that even though we're not simulating that in GNS3, that we're doing this over the internet. So you've got maybe a branch location on the left. They want to talk to the headquarters location on the right. So we're going to set up our phase 1 properties. And then we're going to go in and configure our phase 2 properties so that we can establish the tunnel. We'll set up some basic routing, which will allow us to route the packets to where they need to go. And we'll verify and test our IPsec configuration by taking a look at some of the commands and some of the outputs that are necessary to verify the operation of IPsec. So in order to create this site-to-site IPsec VPN tunnel, there's basically 5 different steps that we have to go through. Possibly 4. The first step may or may not be necessary. Make sure that you have access control lists that are compatible with IPsec. Meaning that on the outside interface of your router, if you are filtering traffic, you have some sort of access control lists that only allow certain traffic in or don't allow any type of traffic in, you need to make sure that you create an access list that allows the protocols that are necessary for IPsec to function. ESP, AH, etc., ISO KMP, and so on. So we'll take a look at what that looks like. I'm not actually going to configure that access list in GNS3 because we don't have any security on our outside interfaces of our routers. So we're going to take a look at what that might look like. But for the most part, we're not going to have to configure that, even in production environments. Then we're going to go ahead and set up our ISO KMP profiles, our policies. Actually, we'll just set up one policy on each router. That's used for our internet key exchange process, or phase 1. We'll set up our IPsec transform set, which is what we're going to use for encryption at phase 2 in the phase 2 process, establishing the actual bulk encryption channel. And then we'll take a look at our crypto ACL. We'll configure a crypto ACL, which is going to identify the source and the destination networks that we're going to try and map the traffic to. And as I go through this, I'll explain what each of these components are for. And then finally, we'll apply everything to our crypto map interface, which is going to then tie the VPN configuration into our outside interface that allows us to communicate across the internet. All right, so these are the 5 basic steps. Essentially, if you're setting up a VPN in an ASA as well, these are the basic principles that you would follow in that kind of case as well. Remember, we're talking about a site-to-site IPsec VPN. We're not talking about DMVPN or GetVPN or even SSL VPN. Those configurations are completely different. Okay? So this is the topology that we're going to kind of follow. Our addressing is slightly different. Our host addressing is the same. Our serial interface is addressed slightly different in our particular case. But we need to establish a VPN tunnel between router A and router B. Let's go ahead and make the assumption that in this particular case, this is our internet here, right? So this address and this address, even though they're technically in our topology reachable directly to each other, in other words, we're not actually technically routing over the internet with default routes and other types of routing, we'll go ahead and still assume that is the internet. Now, site 1, we'll just say that's our branch location, wants to communicate to site 2, which is our HQ location. Well, 10.0.1.3 and 10.0.2.3 are completely different subnets. And these subnets are not routed over the internet. So there has to be a way for us to define reachability between these two endpoints. without routing the traffic over the internet. Of course, we also want to add the security on top of this process to ensure that we have secure communication. This access list here, access list 102, would be defined, if necessary, on the outside interfaces of your routers in combination with whatever access list you might already have there to allow the different IPsec and ISO KMP protocols, right? So the first line there is going to allow AH. The second line is going to allow ESP. Remember, those are IP-based protocols, 51 and 50. Which one is 51 and which one is 50? Protocol 51 is AH and protocol 50 is ESP. So we're essentially saying, okay, let's go ahead and allow those protocols between the two peers. And you would mirror this configuration on the other side if necessary. And then we're going to allow UDP for ISO KMP, and then our non-500 ISO KMP, which is just a different port number that we use for ISO KMP for things like NAT traversal and so on. We don't have to configure this access list in our topology because in our topology, we're not applying any security rules on the outside interfaces of our routers. In the case of our routers, everything is allowed in on these interfaces, which means that ESP and IPsec will work just fine. All right, so the first step in setting up this configuration is to go ahead and establish your crypto ISO KMP policy. All right, in this particular case, we're using a pre-shared key authentication method. We're going to use AES 128 encryption, group 5, Diffie-Hellman group 5, SHA for our message integrity, and we're going to specify a key lifetime of 86,400 seconds. So just to make this a little bit quicker, I'm just going to go ahead and take these commands and I'm going to put them into Notepad. So config T, crypto, ISO KMP, policy, we'll just call it 10 in this case, authentication, pre-shared. So we are going to have to set up that pre-shared key in a little bit. We've identified that we're going to use pre-shared keys to authenticate the peers, but we need to still establish what those pre-shared keys are going to be. Encryption is going to be AES 128. And we're going to use Diffie-Hellman group 5. Remember what Diffie-Hellman group 5 is, or what Diffie-Hellman is? What's Diffie-Hellman used for? Bueller? Anybody? Key exchange, the paint bucket thing, right? And we need at least group 5 to be able to carry enough keying material for AES 128. So 86,400, all right? Now, the policy number does not have to match on both sides of the link. I could use policy 10 on one side. I could use policy 50 on the other side. It doesn't really matter. I don't have to use the same policy number on both sides. But since I'm just doing a cut and paste here, I'm just going to go ahead and use the same policy on both sides of the link. So I'm going to go into my router right here, and I'll paste that in. Of course, I probably spelled something wrong. Authentication, pre-shared. Where did I mistype something? Pre-shared. Yeah. Pre-share. I don't know why I put a D there. All right, so I've got my policy, do, show, run, pipe, section, ISO KMP. So I've got my policy set up. I'm using encryption AES, authentication pre-shared, group 5. Notice that I didn't see the lifetime listed there because the lifetime by default is 86,400. So let's do a show run, and I'll begin at crypto. So we can see the entire policy here. You'll also notice that SHA wasn't listed there because, again, that's default. So it didn't take the hash Well, I mean, it took it, but it's part of the default configuration. All right, so I'm going to go into router number 2 now, paste the same thing. Try that again. All right. So we've now established our phase 1 parameters. Preshared key authentication, encryption AES, Diffie-Hellman group 5, hashing SHA, and lifetime 86400. If you're going to establish a VPN with another peer, obviously you need to make sure that you establish these properties. If it's an extranet, if it's an external customer or whatever, you have to communicate with them and say, okay, what do we want our phase 1 policy to be? What do we want our phase 2 policy to be? Granted, this is ICE v1. This is not ICE v2, but this is the most basic demonstration that we can do. ICE v2 is a little bit more complex in its configuration. Not super complex, but a little bit more complex. As I mentioned before, these routers are going to negotiate the policy. Depending on where the traffic is initiated from and who's trying to establish the VPN, this router here might send its proposals over to router B, or this router here might send its proposals over to router A. It's not the initiator that actually decides on the proposal. If host A is generating traffic, it's going to trigger the crypto process on router A. Router A is going to send all of its proposals over to B, and router B is going to decide or choose which proposal to use based on any of the proposals that match. All right? In this case, these two proposals matched, so we went ahead and chose those policies. All right? Hashing SHA, RSA SIG for authentication, which is just basically digital RSA, PKI. Group 5, 86400, and encryption is AES 256. All right, the next step is to create the pre-shared keys, because we said we were going to identify our peers using a pre-shared key. We need to make sure that both routers identify what key they're using for peer identification. So the pre-shared key gets configured locally on the router to establish how I'm authenticating the remote destination. Notice that the IP address is not the inside network. This peer IP address is the routable address on the internet that I'm using to establish the tunnel. So the pre-shared key needs to point to the neighbor or the peer address on the interface where the tunnel is actually being established. If I go into router 2 here, I do a show IP interface brief. I'm using 172.16.1.2 on this side. And if I do show IP interface brief, I'm using 172.116.1.1 on this side. One of the things that you should always do as part of this process is go ahead and ping the peer address to make sure that you have reachability. Because if you don't have reachability, the VPN is not going to establish its session. All right? In this case, because these are directly connected networks, obviously we have reachability. But again, if this is over the internet, that's something that you would want to test as well. Now, that doesn't necessarily, just because you can't ping, doesn't necessarily mean that you don't have reachability. Because the peer may be blocking ICMP, but allowing all the other crypto protocols through. So if you can't ping, don't automatically assume that you're not going to be able to establish a tunnel. But it's a good indicator, right? Because usually, most of the time, we should be able to ping those outside addresses. All right? So we've verified reachability. Now we just simply need to go in and specify the key. So the command that we use is crypto ISO KMP key. I'll just put that in here. Crypto ISO KMP key. And then we'll put in our key. Now let's just do capital Cisco. And then we put in the peer address. All right, so I'm going to copy this line. We'll go into router number 1, config T, and the peer address is 172.16.1.2. And I'll do the same thing on router 2. 172.16.1.1. All right, so far so good, pretty straightforward. What do you think the next step's going to be? we've established our phase 1 policy. We established our ISO KMP policy. We've established our pre-shared authentication properties. What do you think's next? Do you guys remember? IPsec transform set. We need to identify what we're going to be using at layer 2, or layer 2, phase 2. In other words, what type of encryption are we going to use? If you go back to this slide right here, beginning of the chapter, these are the steps. We did step number 1. We did, we did the pre-shared. They don't actually have that listed here. That's kind of part of the ISO KMP policy. So now we're on step number 2, which is to configure our IPsec transform set. Again, this is what we're going to be doing in the second phase of encryption. So global command, crypto IPsec transform set. We give it a name, whatever name we want, and we specify the bulk encryption and the hashing process that we're going to use for phase 2. We're going to use AES and SHA-HMAC. So let me go ahead and put this in the notepad document. Crypto IPsec transform dash set. We'll just call this crypto. All right. And I'll do ESP AES. We can actually specify, in fact, let me go ahead and just leave that so I can do the question mark so you can see what options we have. So I'm going to go into router number 1. Use a question mark. You can see all the different, all the different encryption algorithms that we have. So these are all the different encryption algorithms that I have available to me. GMAC, GCM, DES, triple DES, actually, really, these are hashing processes. But you can see we have a lot of different options for our encryption. So we're going to use ESP-AES. And now I want to specify the hashing process. We're going to use SHA-HMAC. Actually, we can use all the way up to 512, which would be good. What are they using in this case? They're just using SHA. Okay. So we'll go ahead and implement the same option here. I want to make sure that my outputs look similar to what we see in the book here. This is probably the lowest level of encryption that you would provide and message integrity you would provide in a modern VPN, but we're going to use some of the basic steps here. All right. So let me go ahead and go into router 2. Same thing. You notice that I went into a sub-configuration mode. So there are some options that I can specify here. For example, the mode can be tunnel or transport. By default, it's going to be tunnel mode. I mean, I can come in and specify tunnel mode here, and I can come in and specify tunnel mode here. You guys remember the difference between transport and tunnel? Encrypts the payload plus the original IP header, and it also includes an ESP header. And then we create a brand new tunnel header for transporting the data outside of the ESP, outside of ESP. All right. So we didn't actually technically have to specify tunnel mode. That would have been the default. All right. In addition to, just like we saw with phase 1, where I can have multiple phase 1 policies, on phase 2, I can have multiple phase 2 policies as well. So this is one policy that I might have implemented, but I can implement a whole different combination, a whole bunch of combinations of policies. On the ASA, let me go ahead and pull up ASDM here. On the ASA, when you look at site-to-site VPN and you look at the policy configurations, you can see, actually we don't have any set up here, so let me go ahead and just pull up remote access VPN. You can see that we have several different connection profiles available to us, and these connection profiles are built in automatic. Well, some of the profiles are built in automatically, but when I come into the default group policy, you can see that we have a lot of these phase 1 and phase 2 policies. Come on, pop up. A lot of these phase 1 and phase 2 policies are built in by default within the firewall automatically. It's not popping up. There we go. That's why. All right. Let me find it here.